It's Math with Mrs. Peters, and today she's hoarse. It's because she spent too much time talking over the Thanksgiving holiday. Anyway, today's topic is rational expressions. A rational expression is a quotient of two polynomials. Now, remember what it means to be a quotient. Quotient means that we have a fraction. Okay, and a rational expression actually is a ratio, like 2 to 5 could also be written 2 over 5. So we have two polynomials. Remember what it means to be a polynomial. To be a polynomial, you cannot have a negative in your exponent. You cannot have a exponent that's a fraction. You cannot have a variable that is in the denominator, and you cannot have a variable underneath the radical. Okay, so a rational expression is a quotient of two polynomials. Rational expressions are undefined for values of the variable that cause the denominator to equal 0. Okay, guys, remember, we have a polynomial, say 2x plus 3 over 4x. Okay, and we're going to say that we cannot have anything in our domain that makes the denominator equal 0. So we're going to talk about excluded values at some point. Okay, a rational equation or a rational function, f of x is a function in the form of r of x is f of x over g of x, and this should be an r there, guys, not an f. Where f of x and g of x are polynomials, and g of x is not equal to 0. Okay, the domain of a rational function excludes all values for which the function is undefined. Guys, that's what I just said over here. Okay, in the previous um, page, we just got finished talking about how we can't have 0 in the denominator. Okay, a rational expression is said to be simplified if its numerator and denominator do not have any common factors. And two expressions in the form of a minus b and b minus a are opposite. Because you could write this one here as a minus b. So we have a factor of negative 1. Okay, let's talk about simplifying rational expressions. I'm going to simplify 30 over 84. Okay, that's 3 times 2 times 5. And 84, let's see, that's 2 times, let's do 84. That's 2 times 42. That's 2 times 4, which is 2 times, oops, not 2 times, that'd be 3 times 7, wouldn't it? So I have 2 times 2 times 3 times 7. And what I do when I simplify is I cancel out factors that are in the numerator that are also in the denominator. And I write my answer as 5 over 14. Okay, so we can do the exact same thing when we're talking about rational expressions. Okay, this is 3 times 5 times x times x times x times x over 3 times 2 times x times x times x times x times x times x times x. Yes, guys, there's 7 x's there. And I'm going to use the same idea of canceling out common factors so that I get an answer of 5 over 2x cubed. Now, we can go further with this. We can talk about polynomials that are a little bit more involved, and this is a factored polynomial. Okay, I've already factored it for you. So let's cancel out the common factors. This one, and this one, that one, and that one. And remember, there is always a multiplication by 1. So my answer in this case is 1 over x minus 1. Right, I'm going to caution y'all that when we see a problem like this next one here, you cannot, you cannot cancel out the x squared over the x squared. It has to be in factored form before you can do anything. So what I want you to do is I want you to factor the numerator and I want you to factor the denominator. And I want you to cancel out the common factors. Now guys, we've been practicing factoring polynomials and factoring quadratics for months now, so this should not be out of your ability to factor. With that said, write down any questions. I'll talk with y'all later. Bye.